Good morning. Today we are going to introduce one more important family of organic compounds, that is carboxylic acids. Carboxylic acids. Now what are carboxylic acids? Carboxylic acids are the organic compounds which contain carboxyl functional group. Organic compounds containing carboxyl functional group, they are named as carboxylic acids. So what are carboxylic acids? Organic compounds containing carboxyl group. These organic compounds are called carboxylic acids, and formula of carboxyl group you can write the formula of carboxyl group. Formula of carboxyl group, it is COOH. It is C double bond O OH. This group it is called as carboxyl group. Why this group it is named as carboxyl group? See, in carboxyl group we can see here there is a carbonyl group. C double bond O means carbonyl group. OH means hydroxyl group. So carbonyl group directly bonded to hydroxyl group. So by combining these two words, carbonyl and hydroxyl, we can name this group as carboxyl group. We can name it as what? Carboxyl group. So organic compounds possessing carboxyl functional group, those organic compounds are named as carboxylic acids, and general formula of these carboxylic acids is RCOOH. It is what? It is RCOOH, or I can write ARCOOH. It is what? It is ARCOOH. That is, R means this is aliphatic carboxylic acid. ARCOOH means aromatic carboxylic acid. That is, depending upon the nature of what? Depending upon the nature of the group. Depending upon what? The nature of the group attached to carboxyl functional group. We can have two different types of carboxylic acids. One is aliphatic carboxylic acid. Other one, it is aromatic carboxylic acid. Aliphatic means if we find any alkyl group directly bonded to carboxyl group, then that acid it is called aliphatic acid. Or if we observe an aromatic ring bonded to carboxyl group, then it is named as aromatic carboxylic acid. So depending upon the nature of the group attached to carboxyl group. So depending upon that, we can have two different types of carboxylic acids. They are aliphatic carboxylic acids and aromatic carboxylic acid. One more point we have to remember here, that is, see, higher members. Higher members means number of carbon atoms must be more, that is C12 to C18, higher members of aliphatic acids. Higher members of what? Aliphatic carboxylic acid. Higher members means nearly carbon atoms between 12 to 18. These higher members, they are also called as aliphatic acids. They are also called as what? Fatty acids. So higher members of aliphatic carboxylic acids, they are also named as fatty acids. This is because these higher members of aliphatic carboxylic acids, they are present in natural fats. They are present in natural fats. So since the higher members of aliphatic carboxylic acids, since they are present in natural fats, they are also called as what? They are also called as fatty acids. Next, nomenclature. Nomenclature of carboxylic acids. Nomenclature of what? Carboxylic acids, aliphatic and aromatic carboxylic acids. Let us take some examples. Formula. Here I can write common name. Other one IUPAC name, or it is IUPAC name. Formula, common name, IUPAC name. See, common names of these carboxylic acids, they are obtained from their source or history. From their source or history. So, common names of aliphatic carboxylic acids, they are derived from what? Their source or their history. Whereas IUPAC names, they are derived from the corresponding alkane. From what? From the corresponding alkanes. Okay, I will write the first member. First member of carboxylic acid, it is HCOOH. First member, it is what? It is HCOOH. This acid, it is called as formic acid. This acid, it is named as what? Formic acid. And this formic acid, it is present in red ants. Present in red ants, and in Latin language, formica means ant. Formica means ant. So HCOH is named as formic acid, and source of this formic acid, it is red ant. It is what? It is red ant. What about the IUPAC name? If you observe this formula, there is only one carbon atom in it. So I would write the name of the alkane. It is methane. Alkane containing only one carbon, it is named as methane. So this is methane. Replace this E by oic acid. By what? This suffix, that is oic acid. So name becomes what? Methanoic acid. We know that suffix used for carboxylic acid is oic acid. So name of the acid, methanoic acid. Next example, CH3COH. Common name of this acid, what is the common name? Acetic acid. Acetic acid, and this acetic acid, it is present in vinegar. Present in vinegar. In Latin language, acetum means vinegar. Acetum means what? Vinegar. Now, what is IUPAC name? Two carbon atoms are present. So alkane, it is ethane. On replacing E by oic acid, I will get ethanoic acid. Ethanoic acid. Next, third member, CH3, CH2, COOH. CH3, CH2, COOH. Common name, this is propionic acid. Three carbon atoms are there. Propionic acid. Common name, IUPAC name, propanoic acid. Propanoic acid. Next, fourth one, CH3, CH2, CH2, COOH. This acid, it is present in butter. It is present in butter. Butter means rancid butter. and in Latin language butyrum. Butyrum means butter. So name of the acid butyric acid. Name of the acid it is what? It is butyric acid. So butyrum means butter. So source of butyric acid it is rancid butter. Rancid butter. So acid it is named as butyric acid. IUPAC name, since the total number of carbon atom it is 4 atoms, it is equal to 4. Name of the acid it is butanoic acid. Butanoic acid. CH3 CH CH3 COOH. COOH. So this compound it is having a branch and identical groups are present on either sides, or not on either sides. Total number of carbon atoms it is equal to 4 only. It is equal to 4. So it is butyric acid only, but I have to add a prefix, that is iso. It is iso butyric acid. Common name of this acid it is isobutyric acid. Isobutyric acid. Now what about the IUPAC name? See, this is the parent chain. This is the parent chain and this becomes the substituent group. Substituent group it is present where? Present at carbon number 2. So it is named as 2-methyl. 2-methyl. Number of carbon atoms in the parent chain it is 3. So it is 2-methyl propanoic acid. 2-methyl propanoic acid. IUPAC name, common name it is isobutyric acid. Isobutyric acid. Some more examples we can discuss. Next one, COOH, COOH, or I can write C2H2, C2H2O4, C2H2O4. Name of this acid, common name, oxalic acid. Common name of this acid, oxalic acid. IUPAC name, 2 carbon atoms are present. So it is ethane 1,2 dioic acid. It is ethane 1,2 dioic acid, or it is ethane dioic acid, or we can write ethane dioic acid or ethane 1,2 dioic acid. Carbon number 1 and carbon number 2, they are carboxylic acids, so carboxyl functional groups. So it is ethane 1,2 dioic acid. Next one, COOH, CH2, COOH, COOH, CH2, COOH. This is malonic acid. Malonic acid, IUPAC name, count the number of carbon atoms, total number of carbon atoms it is 3. It is propane dioic acid, or I can write the positions also, propane dioic acid. Next, COH, I will increase the number of carbon atom, it is CH2 twice, COOH, COOH. This is first one, it is malonic acid, this one succinic acid. Succinic acid. Succinic acid contains 4 carbon atoms. So it is butane dioic acid. It is what? It is butane dioic acid. Next, COOH, CH2. Again, I will increase the number of carbon atoms by 1 unit. It is CH2 thrice COOH. CH2 thrice COOH. Name of this acid, glutaric acid. Glutaric acid, malonic acid, succinic acid, glutaric acid. So number of carbon atom it is 5. It is pentane dioic acid. Pentane dioic acid. One more. COOH. Again I will increase the number of carbon atom by 1 unit, that is CH2 4 times COOH. This acid it is called adipic acid. Common name of this acid adipic acid. Total number of carbon atoms present here it is 6. So it is hexane dioic acid. It is what it is, hexane dioic acid, that is adipic acid. We shall consider aromatic acids. Benzene ring containing COH. Benzene ring containing COH. So since there is a benzene ring, this acid it is considered as aromatic acid. Aromatic acid. Common name of this acid benzene plus oic acid. It is benzoic acid. Benzoic acid. IUPAC name it is also same, benzoic acid only, or we can say benzene carboxylic acid. That also I can write benzene carboxylic acid. Benzene carboxylic acid, or it is benzoic acid. Next compound, see benzene ring containing CH2COH. Since this compound it is a derivative of acetic acid. Formula of acetic acid CH3COH. Formula of acetic acid CH3COH. So here one of the hydrogen it has been replaced by aromatic ring. One of the hydrogen it is replaced by aromatic ring. So I can write the name. This group it is named as phenyl group. It is phenyl acetic acid. Phenyl acetic acid. Why it is named as phenyl acetic acid? Because this compound it is a derivative of acetic acid, where one of the hydrogen atom it is replaced by benzene ring or phenyl group. So it is phenyl acetic acid. IUPAC name, see this is the parent chain. Side chain it is considered as the parent chain because side chain contains what? It contains one functional group. Contains one functional group. So this is the parent chain. This is 1 and 2. Functional group should get the least number. So this is carbon number 1, second one. So name becomes 2 phenyl ethanoic acid. Total number of carbon atom it is 2. It is 2 phenyl ethanoic acid. IUPAC name. Common name it is phenyl acetic acid. One more, benzene ring containing 2 COH groups. COH. Common name of this acid it is phthalic acid. Phthalic acid. P silent. It is phthalic acid. Phthalic acid. IUPAC name. So benzene, parent name it is benzene 1, 2, benzene 1, 2, carbon number 1 and carbon number 2, dioic acid, or it is benzene dioic acid. Benzene dioic acid or benzene 1, 2 dioic acid. 1, 2 dioic acid. Okay, this is about nomenclature of aliphatic and aromatic carboxylic acids. Next we are moving on to preparation of carboxylic acids. Okay. Next, preparation. Preparation of carboxylic acids. Preparation of carboxylic acid. First method, from alcohols, primary alcohols and aldehydes. Preparation of carboxylic acids using primary alcohols and aldehydes. Say, primary alcohols, we know the formula of primary alcohol. Primary alcohol formula, it is RCH2OH. RCH2OH. This is primary alcohol. Primary alcohol, when it is subjected to oxidation, by using commonly used oxidizing agents, that is potassium permanganate can be used in acidic medium, alkaline medium or neutral medium also. So potassium permanganate, it is a very good oxidizing agent in neutral, acidic and alkaline medium. Potassium dichromate in acidic medium, other one CrO3, chromic oxide in acidic medium, So these are the commonly used oxidizing agents used for the oxidation of alcohols, primary alcohol. So this primary alcohol, when it is subjected to oxidation by using alkaline KMnO4, alkaline means KMnO4 in the presence of a base, either sodium hydroxide or potassium hydroxide. See, in the presence of oxidizing agent, this primary alcohol undergoes oxidation, forming aldehyde. Due to the loss of water molecule, it will form aldehyde, RCHO. This aldehyde undergoes further oxidation, forming carboxylic acid. So primary alcohol, upon oxidation, forms an aldehyde. This aldehyde undergoes further oxidation because oxidizing agent, it is a powerful oxidizing agent, or it is a stronger oxidizing agent. So oxidation will not stop here. Once aldehyde is formed, this aldehyde further reacts with the nascent oxygen, forming carboxylic acid. Now what happens to this carboxylic acid? Carboxylic acids are acidic in nature. They are acidic in nature. They contain H plus ions. So since they are acidic, they will readily react with the base present in the medium. They will readily react with the base, that is KOH, which is present in the medium or in the solution, forming acid base reaction gives us salt, that is potassium salt. So this will liberate H plus, KOH will give OH minus, H plus and OH will form water. So remaining thing is RCOOK. This is potassium salt of carboxylic acid, and this potassium salt further it is converted to carboxylic acid by adding acid, that is dilute acid. RCOOK upon hydrolysis gives RCOOH, that is upon acidification it gives RCOOH. So no need to write all these things, just write this much. Primary alcohol KMnO4 KOH followed by acidification gives carboxylic acid, that is RCOOH. So this is carboxylic acid. For example, In the place of R, we can take CH3. CH3, CH2, OH. This is ethyl alcohol or ethanol subjected to oxidation using alkaline KMnO4 followed by acidification gives acetic acid. Gives what? Gives acetic acid, or it is ethanoic acid. Ethanoic acid. One more example we can take CH3, CH2 8 times, CH2OH. Total number of carbon atoms present in this compound, it is 10. 8 plus 2. 8 plus 2, it is 10. So this is decanol, or it is 1 decanol. 1 decanol. When it is subjected to oxidation using acidified chromic oxide, acidified chromic oxide, this will form an acid, that is CH3, CH2 8 times, COOH. Number of carbon atoms will be retained as it is. Primary alcohol. In the case of primary alcohol, formed carboxylic acid contains same number of carbon atom as that of parent alcohol. See, parent alcohol contains 10 carbon atom. So formed acid also contains 10 carbon atom. This acid is called decanoic acid. What is this? Decanoic acid. So this is about oxidation of primary alcohols. So primary alcohols, upon oxidation, that is by using either potassium permanganate, potassium dichromate or chromic oxide in acidic medium, they will form corresponding carboxylic acid. Suppose if we are using alkaline KMnO4, instead of carboxylic acid, we will get a salt due to acid base reaction, and that salt once again it is converted back to acid by acidification. By what? By acidification. So it is necessary to carry out acidification to convert carboxylic acid salt into carboxylic acid. Now what about aldehyde? See, formula of aldehyde, that is RCHO. Formula of aldehyde, it is what? It is RCHO, and this aldehyde can be converted into what? Into carboxylic acid even by using mild oxidizing agents, that is Tollens reagent or Felling's reagent. Tollens reagent or Felling's reagent. In the last class we discussed. See, Tollens reagent, Felling's reagent, they are examples for mild oxidizing agents. Even in the presence of mild oxidizing agents, these aldehydes will undergo oxidation forming carboxylic acid. Forming what? Forming carboxylic acid. So either by using stronger oxidizing agent or by using milder oxidizing agent, we can oxidize primary alcohols and aldehydes. Primary alcohols and aldehydes. So this is about preparation of carboxylic acids using primary alcohols and aldehydes. Next, second method. From alkyl benzene. From alkyl benzene. So from alkyl benzene means, benzene means we are preparing aromatic acid. Preparing what? Preparing aromatic acid. So example for alkyl benzene, methyl benzene. Methyl benzene, it is also called as toluene. Methyl benzene, or it is toluene. Now this methyl benzene, when it is subjected to oxidation by using alkaline KMnO4, by using alkaline KMnO4, the side chain readily undergoes oxidation. Side chain readily undergoes oxidation, correct? So this is the side chain CH3. This CH3, it is undergoing oxidation in the presence of alkaline KMnO4. In the presence of what? Alkaline KMnO4. So irrespective of the length of the carbon chain, means side chain may contain 1, 2, 3, 4 or 5 carbon atom. Whatever may be the length of the carbon chain, whole carbon chain will be converted to carboxylic acid. Converted to what? Converted to carboxylic acid. So methyl benzene upon oxidation using alkaline KMnO4, it will give what? It will give aromatic acid containing, aromatic acid means what? Containing COOH. Now what happens to COOH? Once again same concept. Carboxylic acids are acidic. Reaction it is taking place in basic medium or alkaline medium. This acid reacts with the base forming salt. So here this base will liberate OH minus, acid liberates H plus. So thereby COOH it is converted to what? Converted to potassium salt. It is COOK. COOK. This is potassium salt. Potassium salt of carboxylic acid. Potassium salt of carboxylic acid. Now this potassium salt upon acidification using a mineral acid, using what? Using a mineral acid gives COOK becomes COOH. This acid it is named as benzoic acid. Benzoic acid. So methyl benzene upon oxidation gives potassium salt of carboxylic acid. Further upon acidification it will form what? Benzoic acid. I will take one more alkyl benzene. Instead of methyl benzene, I will take propyl benzene, that is CH2, CH2, CH3. This is propyl benzene. Propyl benzene. Now this propyl benzene, when it is subjected to oxidation using alkaline KMnO4, already I told you, whatever may be the length of the carbon chain. So first compound contains only one carbon. What about this one? It contains 3 carbon atom. Whatever may be the length of the carbon chain, whole carbon chain, it is converted to carboxylic acid, that is potassium salt. Upon acidification it gives aromatic acid, that is benzoic acid. Benzoic acid. So maybe butyl benzene, propyl benzene, ethyl benzene or methyl benzene, its oxidation always forms benzoic acid. Always forms benzoic acid. Then what about remaining carbon atoms? See, aromatic acid contains only one carbon. Initial compound contains 3 carbon atoms. So other 2 carbon atoms, they are removed in the form of carbon dioxide and water. In the form of what? Carbon dioxide and water. Third method, from nitriles and amides. Preparation of carboxylic acids using nitriles and amides. See, we know the formula of nitrile. So what are nitriles? Nitriles are the organic compounds which contain CN functional group, that is R C triple bond N. This is nitrile. This is the formula of nitrile, alkane nitrile. When this nitrile, when it is hydrolyzed by using either dilute solution of an acid or by using dilute solution of a base, aqueous solution of a base, or by adding dilute acid, so I can write H plus means acid, OH minus means base, Dilute solution of an acid or dilute solution of a base. Okay, so by using dilute solution of acid or dilute solution of base, we are carrying out hydrolysis of what? Nitrile. See, in nitrile, we know that nitrogen, it is more electronegative compared to carbon. So, shared pair of electrons will be shifted towards what? Towards nitrogen. As a result, nitrogen gains partial negative charge, carbon gains partial positive charge. Carbon gains what? Partial positive charge. Now, what about water? See, in water, it is made up of what? H plus ion and OH minus ion. H plus ion and OH minus ion, and this OH minus ion acts as the nucleophile and will attack the carbon atom. It will attack what? Carbon. So once it attacks carbon atom, these electrons, already there was partial transfer, now electrons will be completely shifted to nitrogen. So as a result, we will get R, C, here outright OH, triple bond becomes double bond, it is NH. So this H will be added. Okay, so negative part it is added to carbon, positive part it is added to nitrogen, NH. Now this compound contains double bond and OH group. OH means alcohol, OL. Double bond means En. So this is enolic form. It is what? It is enolic form. See, we know that enolic form can be converted to keto form. Enol keto isomerism, or it is called as tautomerism. So okay, so this enolic form readily undergoes a bond cleavage. See, OH bond, it is a polar bond. That bond will break in the medium or in the solution, and electrons will be shifted like this. Okay, so we will get R, C, double bond O. This bond shifts here between carbon and oxygen. Double bond becomes single bond. This is NH minus. It will accept this H, forming NH2. Forming NH2. Understood? Forming NH2. This is amide. What is this? Amide. So nitriles upon hydrolysis gives enol, and this enol isomerizes, or it is interconvertible. Enol form isomerizes to form what? To form keto form. This is keto form, forming an amide. Okay. So this amide on hydrolysis, I will write the hydrolysis here, either acid hydrolysis or alkaline hydrolysis, it loses ammonia. Upon hydrolysis, it loses ammonia, forming what? Forming R, C double bond O. Here there is OH group. So RCOH along with ammonia. So nitriles upon hydrolysis forms an amide. Amide upon further hydrolysis gives carboxylic acid. Now we can write examples, 1 or 2 examples for this. This is H plus or OH minus. Initially we will get an amide, RCONH2. This amide again on hydrolysis gives carboxylic acid along with ammonia. For example, CH3 CONH2, it is called as what? Acetamide. Name of the compound acetamide, or it is ethanamide. 2 carbon atoms are there. Acetamide or ethanamide. Upon hydrolysis, it gives out acetic acid. So hydrolysis means like this. So it loses ammonia, forming acetic acid plus NH3, acetic acid plus ammonia. If I take aromatic amide, benzamide, C6H5NH2, this is benzamide. Upon hydrolysis gives benzoic acid, C6H5COOH along with ammonia, benzoic acid and ammonia. So this is about the preparation of carboxylic acids using what? Using nitriles and amides. One more we can discuss. Fourth one, preparation of carboxylic acids using Grignard reagent. Preparation of carboxylic acids using Grignard reagent. Now what are Grignard reagents? Grignard reagents, they are nothing but alkyl magnesium halides. And general formula of Grignard reagent, it is RMgX. Formula of Grignard reagent, RMgX, where R represents alkyl group, Mg it is magnesium, X means halide. Now this Grignard reagent, when it is made to react with solid carbon dioxide, also called as dry ice. Grignard reagent, when it reacts with solid carbon dioxide or dry ice, nucleophilic addition takes place. Correct. So which is the nucleophile here? In Grignard reagent, we know that metal carries positive charge, carbon carries negative charge. Because metals are electropositive, readily loses electron. So metal always possesses positive charge, carbon possesses negative charge. What about carbonyl group? See, in carbonyl group, carbon it is positively charged, oxygen it is negatively charged. Now I can write the nucleophilic addition. See, this is the nucleophile. It will attack the positive center, carbon. R minus readily attacks positively charged carbon. So once it attacks here, one of the shared pair will be shifted to oxygen. Already there was partial transfer of electron. Now complete transfer of electron takes place towards oxygen. So here above the arrow mark I have tried dry ether. So for the reactions of Grignard reagent, dry ether is used. Okay. So I can write C double bond O. This carbon it is attacked by the nucleophile, that is the R. Here I have double bond become single bond now. O minus, correct, O minus, and this O minus will take up this positive part, that is MgX. So it becomes OMgX. What is this? This compound it is nothing but salt of carboxylic acid. Now this carboxylic salt, here I will write, next it is subjected to acid hydrolysis, or I can write H plus bar H2O. So hydrolysis we know, we have to break this compound by adding water. So here bond cleavage will take place, because bond present between oxygen and magnesium it is weaker. It is a polar bond. This bond readily undergoes cleavage. Now in between these two, magnesium it is positively charged, correct. Oxygen it is negatively charged. So since oxygen contains negative charge, positive part of water, that is H plus, will be added here. Negative part of water it is added to magnesium. So H plus it is added to oxygen, OH minus it is added to magnesium, thereby that compound it is decomposed. So final product formed, it is R, C double bond O, OH, C double bond O, OH. This is carboxylic acid plus it is what? It is MgOHX. MgOHX. Very important reaction. This question can be asked in the exam. How do you prepare carboxylic acids using Grignard reagent? Using what? Using Grignard reagent. Now, what we have to write? When Grignard reagent reacts with solid carbon dioxide, Grignard reagent reacts with solid carbon dioxide or dry ice, nucleophilic addition reaction takes place, or generally you can write addition reaction takes place forming salt of carboxylic acid. See, negative part it is added to carbon, positive part it is added to oxygen, will get a salt of carboxylic acid, and this salt of carboxylic acid further it is hydrolyzed by adding dilute solution of an acid, or it is acid hydrolysis. Upon acidification, we will get two compounds, one is carboxylic acid, other one is addition compound of magnesium, that is MgOHX. MgOHX. So, this is about preparation of carboxylic acids using Grignard reagent. In the next class, we are going to discuss two more methods of preparation of carboxylic acid. Let us discuss it in the next class. Thank you.